Close your eyes. Let the sounds of your world fade away. Tonight, we are not bound by gravity or time or the limits of our own biology. We are travelers, and our vessel is the most powerful eye humanity has ever opened to the cosmos, the James Webb Space Telescope. We are journeying back further than ever before to the cosmic dawn, a time just a few 100 million years after the Big Bang. We expected to find cosmic infants, small chaotic clusters of gas and dust just beginning their long journey to becoming galaxies. But instead, Webb saw something else, something impossible. It saw giants where there should have been newborns, order where there should have been chaos. Tonight, we explore the forbidden discovery, the cosmic paradox that is shaking the very foundations of what we know about our universe. For decades, our understanding of the universe has been guided by a beautiful, elegant theory called the Lambda-Cold Dark Matter Model, or Lambda-CDM for short. It's our best map of cosmic history. This model predicted a very specific story for the early universe. It told us that after the Big Bang, the universe was a dark, simple place filled with hydrogen and helium gas, threaded with invisible, dark matter. Over hundreds of millions of years, gravity would slowly, patiently pull this matter together. The first stars would flicker into existence, tiny and fragile. These would then cluster into small, irregular proto-galaxies. Only after billions of years of patient merging and growth would we see the majestic, well-formed spiral and elliptical galaxies we know today. The universe, according to our story, was a slow developer. This was the expectation. This was the story Webb was sent to confirm. But the universe, it seems, had a different story to tell. Imagine a magnificent, golden honeycomb, unfolding silently in the freezing vacuum of space, 1,000,000 miles from Earth. This is the heart of the James Webb Space Telescope. 18 perfect hexagonal mirrors, coated in a whisper-thin layer of pure gold, working together as one giant eye, 6.5 meters across. Gold is not just for beauty. It is the perfect reflector for infrared light, the ancient, stretched-out light from the dawn of time. This is the light that has traveled for over 13.5 billion years to reach us. It is a fossil, a remnant of the universe's first breath. The telescope itself must be incredibly cold, colder than any natural place on Earth, shielded from the sun by a 5-layered sun shield the size of a tennis court. Each layer is thinner than a human hair, but together they create a sanctuary of deep cold, allowing Webb's sensitive instruments to listen for the faint, cosmic whispers from the past. Webb's journey to its final destination was a ballet of perfect engineering. Launched on Christmas Day of 2021, it traveled for a month to a special point in space known as the second Lagrange point, or L2. This is a place of gravitational stability, where the pull of the sun and the Earth balance out, allowing the telescope to orbit the sun in lockstep with our planet. It is a lonely, quiet place, far from the heat and light of Earth. It is the perfect vantage point for a time machine. During its journey, it performed a series of deployments so complex, they were called 30 days of terror by the engineers. Hundreds of individual steps had to work perfectly, from the sun shield unfolding like a giant silver butterfly, to the golden mirrors clicking into their final, precise configuration. It was a flawless performance, a testament to human ingenuity, all for the sake of one goal: to see the unseen. And then the first images arrived. Scientists and the public alike held their collective breath. What we saw was breathtaking. One image, called Webb's first deep field, focused on a patch of sky so small it could be covered by a grain of sand held at arm's length. And in that tiny speck of darkness, Webb revealed not hundreds, but thousands of galaxies. Each point of light, each smudge of color, was an entire galaxy, home to billions of stars and worlds. Some were warped and bent by the gravity of a foreground cluster, creating cosmic arcs of light, a phenomenon known as gravitational lensing. It was a portrait of the universe in a depth and clarity never before witnessed. It was beautiful. It was overwhelming. And hidden within it was the seed of a profound mystery. The images were a cosmic census, and the numbers were not adding up. As astronomers looked closer at the faintest, reddest smudges in these deep fields, they were looking at the oldest light. These were the galaxies from the universe's childhood, existing just 300 to 500 million years after the Big Bang. The universe itself was less than 3% of its current age. According to our established theories, these galaxies should have been small, messy, and dim. They should have been the cosmic equivalent of tiny flickering embers, just beginning to glow in the vast darkness. They were expected to be little more than loose collections of the very first generation of stars, still finding their form. But that is not what Webb saw. It was like expecting to hear the first tentative notes of a symphony, and instead being met with a powerful, fully formed orchestra. Instead of faint, chaotic blobs, Webb saw galaxies that were shockingly bright. They were far more luminous than predicted, suggesting they were filled with a surprising number of massive, brilliant blue stars, all burning with incredible intensity. Furthermore, some of them had a distinct structure. Webb detected galaxies with flattened disks, a feature that was thought to take billions of years of slow, gravitational settling to form. It was like finding a perfectly sculpted marble statue in a primordial quarry where only rough, uncut stones should lie. These galaxies were not infants. They seemed to have been born mature, skipping their cosmic childhood entirely. The discovery was so startling that some of the scientists who found them initially thought their instruments were broken, that there must be an error in the calibration. Let's call these cosmic anomalies the impossibly early galaxies. One of the most famous examples is a group of 6 candidate galaxies that appear to be as massive as our own Milky Way, but seen at a time when the universe was just a tiny fraction of its current age. For a galaxy like the Milky Way to form, it needs to gather hundreds of billions of stars, along with vast amounts of gas and dark matter. Our models said this process should be slow and steady, taking billions and billions of years. To find a galaxy of that size, so early in cosmic history, is like finding a 10-year-old child who is already 6 feet tall and has a deep, resonant voice. It violates our understanding of the normal growth rate. It suggests that the universe was building its largest structures far faster than anyone ever dreamed. This presents a fundamental crisis for cosmology. Our standard model is built upon the idea of hierarchical formation. Small things form first and then merge, to create larger things. Small star clusters merge to form small galaxies. Small galaxies merge to form big galaxies. It's a bottom-up process. These discoveries suggest the universe might have also employed a top-down approach, or something else entirely. It's as if the universe had a secret recipe for building massive structures almost overnight. This doesn't just tweak the timeline. It forces us to question the very physics of galaxy formation. The smooth, predictable story we told ourselves about the early universe has been replaced by a more chaotic, more dynamic, and far more mysterious reality. The implications ripple outwards, touching every aspect of our cosmic story. To form so many bright stars so quickly, you need a tremendous amount of fuel, specifically cold hydrogen gas. The universe must have been far more efficient at cooling this gas and collapsing it into stars than our simulations predicted. Imagine trying to build a bonfire with damp wood. You'd expect a slow, smoky start. The early universe was supposed to be like that. Instead, it seems the universe had perfectly dry kindling and an endless supply of it, creating raging stellar infernos almost immediately after the Dark Ages ended. Something in our understanding of the cosmic environment, the very nursery of stars, seems to be missing. And then there is the question of black holes. At the center of most large galaxies, including our own, lies a supermassive black hole, millions or even billions of times the mass of our sun. These cosmic behemoths are thought to grow alongside their host galaxies. But the process of growing a black hole is also thought to be slow. It needs to feed on gas, stars, and other black holes. To find well-formed, massive galaxies so early implies that they might also host surprisingly large black holes. This deepens the mystery. How could a black hole grow to be millions of times the mass of the sun in just a few 100 million years? It's a cosmic riddle, wrapped in an enigma. So, what could be the answer? Scientists around the world are now scrambling to find an explanation. One possibility is that the very first generation of stars was different from the stars we see today. These hypothetical population 3 stars were forged from pure hydrogen and helium, the raw elements of the Big Bang. Because of this, they could have grown to be truly monstrous, hundreds of times more massive than our sun. These titans would have lived fast and died young, burning incredibly brightly and collapsing into massive black holes, providing the seeds for the giants Webb is now seeing. Perhaps the universe began not with a whisper, but with a roar of these cosmic giants. Another fascinating idea involves the silent architect of the cosmos, dark matter. We know this mysterious, invisible substance makes up about 85% of the matter in the universe. Its gravity provides the scaffolding upon which galaxies are built. Our standard model assumes that dark matter is cold, meaning its particles move slowly. This leads to the slow, bottom-up formation of cosmic structures. But what if dark matter isn't so simple? What if some of it is warm or interacts with itself in strange ways? A different kind of dark matter could have caused the cosmic web to collapse into massive structures much faster, giving galaxies a significant head start. Webb's discovery might not be a problem with galaxies, but a clue to the true nature of darkness itself. There is also the theory of primordial black holes. This idea suggests that in the chaotic first moments after the Big Bang, intense fluctuations in density could have caused some regions of space to collapse directly into black holes without it ever having been a star. These primordial black holes could have come in all sizes, from microscopic to thousands of times the mass of the sun. If they existed, they would have been scattered throughout the early universe like seeds in a fertile field. These pre-made gravitational anchors could have rapidly collected gas and dark matter, jump-starting the galaxy formation process and explaining the massive structures Webb is observing. It's a compelling, if unproven, idea. We must also consider the possibility that we are being tricked by the light itself. The universe is full of dust, which can absorb the light from young blue stars and re-radiate it in the infrared, making a galaxy appear older and redder than it truly is. However, astronomers are using Webb's powerful spectrographs to analyze the chemical fingerprint of the light from these galaxies. This allows them to more accurately determine their distance and properties. So far, the data seems to confirm the initial, shocking conclusion. These galaxies are indeed very distant, very old, and very, very big. The cosmic mirage theory is fading, leaving us to face the profound reality of what we are seeing. This entire situation highlights a beautiful aspect of science. A great theory is not one that can never be proven wrong. A great theory is one that makes testable predictions. The Lambda-CDM model made a clear prediction about the early universe, and the James Webb Space Telescope was built to test it. Now it appears the prediction was wrong. This is not a failure. This is a triumph. It means we are on the verge of a deeper, more complete understanding of the cosmos. Every great leap in science has been preceded by a moment of confusion, a moment when the data refuses to fit the story. We are living in one of those moments right now. Let's drift back in our minds to one of these early galaxies. Picture a place bathed in a brilliant blue-white light. The stars here are giants, burning with a ferocity we can barely imagine. They are packed together much more closely than in our own Milky Way. There is no quiet, peaceful night sky here. The heavens would be a constant, blazing canopy of light. Explosions from massive supernovae would be a common sight, seeding the galaxy with the first heavy elements, the building blocks of future planets and perhaps life. It is a chaotic, violent, and incredibly creative environment. It is the crucible of the cosmos, working at a pace we never thought possible. The very definition of a galaxy might need to be re-examined. We think of them as stable, long-lived cities of stars. But perhaps these early structures were more like temporary, brilliant bursts of star formation, more like cosmic flashbulbs than enduring cities. They might have burned through their fuel incredibly quickly, flaming into existence with astonishing mass, only to fade or be consumed by others just as rapidly. Webb might be showing us a different mode of cosmic existence that was only possible in the unique, dense conditions of the infant universe. We are witnesses to a forgotten age with different rules. This mystery also forces us to reconsider time itself. A few 100 million years sounds like an eternity to us, but on a cosmic scale, it is the blink of an eye. The universe apparently managed to go from a smooth, uniform state to building structures as massive as the Milky Way in a geological instant. This suggests that the processes governing the universe can operate with an efficiency and speed that defies our terrestrial intuition. It's a lesson in humility. The cosmos does not operate on a human timescale, and its creative power in its youth was far greater than we ever gave it credit for. Could there be an even more radical explanation? Some fringe ideas speculate about physics beyond our standard model. Could gravity have been stronger in the early universe? Could the cosmological constant, the force driving the universe's expansion, have changed over time? These are wild ideas, far from the mainstream, but discoveries like this are what push scientists to think outside the established box. A discovery that breaks the model is an invitation to dream up a new one, to imagine a universe that is even stranger and more wonderful than we previously thought. The search is now on for even older galaxies. Webb is pushing the frontier back further and further, looking for light from just 200 million or even 100 million years after the Big Bang. What will we find there? Will we finally see the true cosmic infants we expected? Or will we find that the mystery only deepens, that even at the very edge of time, the universe was already busy building giants? Each new image is a page from a book we've never read before, and we have only just begun to turn the first few pages. The story is just getting started. There is a deep philosophical comfort in this discovery. It reminds us that the universe is not a solved puzzle. It is not a machine whose workings we have fully deciphered. It remains a place of profound mystery and endless surprise. For anyone who has ever looked up at the night sky and felt a sense of awe, this is wonderful news. It means there are still grand secrets to uncover, still fundamental truths to learn. Our map of reality is incomplete, and there are vast, uncharted territories waiting to be explored. The journey of discovery is far from over. Imagine the feeling of the astronomers who first saw this data appear on their screens. A mix of disbelief, excitement, and even a little bit of fear. The fear of being wrong, the fear of overturning decades of established thought. But that is the thrill of exploration, to be the first to see something that no human has ever seen before, to be the one to find the piece of the puzzle that doesn't fit. It is a moment of pure discovery, a connection to the fundamental fabric of reality. It's a reminder that we are a species of explorers, and the universe is our ocean. These impossible galaxies are not just scientific curiosities. They are our oldest ancestors. The heavy elements forged in their giant, short-lived stars, the carbon, the oxygen, the iron, were cast out into the cosmos by supernova explosions. Over billions of years, this cosmic dust would collect, form new stars, new planets, and eventually us. The story of these impossibly large, impossibly early galaxies is the first chapter in our own origin story. By understanding their birth, we get one step closer to understanding our own existence. We are, quite literally, looking at our own family album. Think about the light from one of these galaxies. For 13.5 billion years, it has traveled through the expanding, darkening universe. It has journeyed across unimaginable voids, past countless other galaxies, and through cosmic clouds of gas and dust. For all of human history, it was flying towards us, unseen and unknown. It traveled while dinosaurs roamed the earth, while ice ages came and went, while civilizations rose and fell. And finally, at the beginning of the 21st century, it ended its long journey on a golden mirror, 1,000,000 miles from home, to be captured and seen by a curious, intelligent species on a small blue planet. It is a profound connection across time and space. The process of solving this puzzle will take many years. It will require new simulations, new theoretical models, and countless hours of observation from Webb and other telescopes. There will be debates, disagreements, and dead ends. But slowly, a new picture of the early universe will emerge. It will be more complex, more interesting, and more beautiful than the one it replaces. That is the promise of science. It is a self-correcting journey towards a deeper truth, a journey fueled by curiosity and guided by evidence. And we are privileged to be alive to witness this revolution in our understanding. This cosmic mystery is a gift. It forces us to stretch our minds, to imagine possibilities that seem impossible. It challenges our assumptions and pushes the boundaries of our knowledge. In a world often filled with simple answers and certitudes, the universe presents us with a question that we cannot yet answer. And in that not knowing, there is a kind of freedom. A freedom to wonder, to speculate, and to dream. It is an invitation to be comfortable with mystery, to embrace the vastness of our own ignorance in the face of a majestic and incomprehensible cosmos. The implications of this rapid formation are staggering. If massive galaxies can form this quickly, it might mean that the conditions for life could have arisen much earlier in the universe's history than we previously thought. Heavy elements, rocky planets, and stable environments, the prerequisites for life as we know it, might have been available billions of years sooner. This doesn't mean life existed back then, but it widens the window of opportunity. The search for life elsewhere in the cosmos is often a search for planets that are old and stable. Webb's discovery hints that such places might be far more ancient than we dared to imagine. Let us also appreciate the sheer beauty of the unknown. When we look at these images from Webb, we are not just seeing data points, we are seeing a new cosmic vista. The colors, the shapes, the sheer scale of it all is a form of cosmic art. These ancient galaxies, with their impossible brightness and structure, are like brushstrokes from the universe itself, painting a picture of its own fiery birth. We do not need to fully understand them to be moved by their beauty. We can simply float in the mystery, allowing the sense of wonder to wash over us, a calming balm for the busy mind. It is also a story about perspective. On Earth, our problems can feel enormous, all-consuming. But when you contemplate a galaxy 100 billion times the mass of the Sun, that existed 13.5 billion years ago, your own concerns begin to shrink. When you witness a mystery that challenges the minds of the most brilliant scientists on the planet, you realize that it is okay not to have all the answers. The universe is vast, and our time within it is short. This perspective is not meant to diminish our lives, but to enrich them, to fill them with a sense of awe and connection to something much, much larger than ourselves. So as you continue to drift deeper into relaxation, hold this image in your mind. The image of a young universe, not quiet and slow, but furiously, brilliantly alive, a universe that was building majestic cities of stars while it was still in its infancy, a universe that is more creative, more efficient, and more surprising than we ever knew. It's a universe that doesn't always follow our rules or our expectations. It writes its own story, and the James Webb Space Telescope is our translator, allowing us, for the first time, to read the opening lines. The mystery of the impossible early galaxies is not a problem to be solved and forgotten. It is a doorway. It is an opening into a new realm of cosmology. Behind that door lies a deeper understanding of dark matter, of star formation, of the very laws of physics that govern our reality. Webb has given us the key, and we are just now turning it in the lock. What we find on the other side will shape our understanding of the cosmos for generations to come. And it all started with a few smudges of reddish light that traveled from the beginning of time just to tell us that the story was more magnificent than we ever imagined. So we find ourselves back from our journey to the dawn of time, carrying with us a profound and beautiful puzzle. The James Webb Space Telescope, our eye in the silent darkness, has shown us that the universe's childhood was not what we expected. It was not a slow, quiet crawl, but a brilliant, roaring sprint. It built galactic giants with impossible speed, challenging the very story we tell about our cosmic origins. This isn't a failure of our science. It is its greatest success. It is a sign that we are peeling back a layer of reality to find something even more wondrous underneath. The universe is not broken. Our understanding is simply growing. Thank you for joining me on this peaceful journey into one of the greatest cosmic mysteries of our time. May it fill your dreams with wonder. For more journeys into the heart of the cosmos, please consider subscribing and liking this video. Your support allows us to continue exploring these vast ideas together. Now I leave you with a question to ponder as you drift into sleep. What other cosmic secrets do you think are waiting for us, hidden in the ancient light of the stars? Sweet dreams.